So here's another COVID-19 lockdown project, something I'd been meaning to get around to. This looks an awful lot like an Arduino Nano in a 40-pin DIP package. This is a product they call the EZ SBC. The company that makes this is a US company that designs and manufactures in the US, and they have a whole line of tiny little switching regulator power supplies that are designed to replace traditional and common linear supplies. And they also have this product, which is very much like an Arduino Nano, except that it is not programmed the same way. It's programmed in a control version of the BASIC language. And you can use it very much like an Arduino Nano, except, again, the programming environment is different. And you don't need any programming software to program it, because all you need to do is hook it up to a terminal or a terminal emulator through USB and run that terminal emulator or terminal, and everything you need is right there, so you don't need to load any programming software on your computer. There's also a product like this, which is sort of a development or experimenter's board, into which you can plug this product, and there's a little breadboard area, power supply, some relays, an LED that you can turn on, some push buttons, battery for the real-time clock, photocell, all sorts of provisions for hooking things up. The relay contacts are brought out to terminal blocks, and you can power this by itself from USB, but you don't always want it plugged into USB. So if you hook it up to something like this, or another circuit that you'd plug it into, then it's powered off of that. Now for this product, you can just use any of the myriad inexpensive AC power supplies with a barrel connector providing, I think it's 9 volts that it requires. Yeah, 9 volts. But right now I'm just going to see if this thing works. I've got it plugged in, and let's see here. I'm going to go here and launch TerraTerm, and close that. Expand my window a little bit. Go to Setup and Restore Setup from my TerraTerm EZSBC. Open, and I don't think I was pointing the camera in the right place, but boy, this camera does not want to expose properly. So let's see here. Set up serial port. It looks like it's got all the right settings there. The right driver. I'm just going into my device manager and making sure that my driver down here is still on COM4. I'm going to unplug it and replug it. Okay, I've unplugged it. I've replugged it. It does show it there, and it's still on COM4. So let's see here. Serial port. It's COM4. COM1. COM4. $57,600 baud, 8 bits, none, 1 bit X on, X off, 0, 0. I'm just going to do new open here. There we go. I just needed to click that setting to confirm it. So it's popping up with basic version 0.82, and there are commands for run, step, list, edit, configure, bbank, download, k-reset, t-time and date. So that is the environment that is presented just on a terminal emulator without any other programming software. Now I have to push the reset button on the product here, that's that little white button, and see what happens here. Cold start. Alright. I should be able to do the same thing with the K command. Reset from the keyboard, so I'm going to try that. Yep, I got a cold start. So now I'm ready to try entering a test program, which I'm going to do without the camera rolling. The first thing I need to do is get into the editor, which requires me to push the E key. Now I'm in the editor. And I can push Control backspace to get a help screen. And there's my help screen. Push any key to continue. Okay, I'm back at my editor again. So now I'm going to plug in a little program. Okay, here's the program. The little apostrophe, I believe, is the indicator for a comment. So in other words, it's not an instruction that follows it. We're calling this Blinky. It flashes the red LED. There's a pin mode command assigned to the red LED code word. It establishes an output. Pin 41 is the output pin. Then there's a repeat. I think that's the equivalent of a loop. There's an output D. I think that means digital output command associated with the red LED word, comma 0, which turns the LED on. Then there's a wait 100, do nothing for 100 milliseconds. Come on, camera, focus. And then another out D, red LED, comma 1, turn LED off. So apparently the LED's off when the bit is on. And it'll do that until it reads a key from the keyboard that's greater than -1. I don't know exactly how that works. I'm just taking this out of the manual, and then it ends the program. Now if I hit Control W, it should process that and maybe reformat it a little bit. Save file, yes or no? Yes, so that was what's supposed to happen. It's just that the instructions are written weirdly. So it's asking me again to save the file, and press Y to save, and it's saved. It didn't ask me where to save it, so I'm going to have to read more about how it does that. Maybe it just calls it by that opening name. I don't know yet. Now I should push I to make the EZMon, that's the program we're in here, list the program. So, yeah. The manual's got some problems because it'll say things like, press this. That looks like an I to me, but because of the font they're using, it's indistinguishable from a lowercase l. And yet the prompt here says L is for listing, so they could have done better with that. I'm going to push L. And so it lists it with some things I get capitalized, some words like pin mode that I had lowercase. All the commands are capitalized now, but it doesn't seem to have indicated any syntax error. And it says, see how many words are now in uppercase. The interpreter is actually also a tokenizer. It's recognized those words as valid basic or control basic reserved words, and they will now be displayed in uppercase. So that seems to have been good. We're now ready to run, so I push R, and there should be a red LED on here that will flash. So I'm going to push R. And it's supposed to do it until I push a key, so I'm going to push M. And the LED turned off. It says program ended, but it did not flash the LED. It turned it on. There seems to be some sort of a problem. I don't know if the time delay was really long or if I've done something else wrong. I need to investigate. I've gone back into the editor. I'm just going to see what happens. Since at 100 milliseconds each time delay, it should flash 5 times per second, and maybe that this is actually a different version. This is I think the older version of the product. The manual is written for a newer version. There may be some differences in the clock frequency. Maybe this older one needs a longer time delay. So I can edit down to this line. What about if I make it 500? And what happens if I hit enter? No, it breaks it. Ah! Okay. I go to the end. That's also not what I want. Control W. Save file. Yes. Okay, now I should be able to list. And I have changed my time delay to 500. So what if I run it now? Pushing R. Nope, still doesn't flash it. The program runs, it just doesn't flash the LED, so I need to revisit that. Well, I just figured out that I made a blunder in entry of my program. It doesn't actually make sense this way. I'm only doing a time delay between turning the LED on and turning it off, but then it loops around and immediately turns it back on. There's no time delay for how long it's off. I need to put another time delay in there, so I'm going to go back and edit again. See if I can get the camera to focus. Change that to 100. Go to the end of this guy and hit enter. Tab over and wait 100. Okay, Control W should get out of that. I want to save it, yes. Now I'm going to list it. Verify that's in there. And now I'm going to go and try running it again. There we go. So that makes sense. I believe that LED is also associated with a pin, although it says pin 41. I don't think this has 41 pins, so maybe there are virtual pins that are tied to those LEDs starting with 41. I don't know. I've just started the manual and I haven't read everything about this yet. But I did want to make sure that my communications were working and that I could communicate with it via TerraTerm. I didn't have any serial link issues. And it seems to have worked perfectly once I got over a couple of little stumbles. So I'm going to push a letter here to end the program. Alright. So I'm reading through the description here of the programming. The first line, Blinky, flash the red LED as a comment. Comments start with the apostrophe and end at the end of the line. The next line is red LED equal 41. That's where it gets assigned to pin 41. It assigns the value 41 to a variable called red LED. Pin 41 on the EZ SBC is a phantom pin to give easy access to the onboard red LED. That's what I thought. 3 more phantom pins exist, 42, 43, and 44, for controlling the yellow, green, and blue LEDs. Setting these pins to outputs and low turns the LED associated with the phantom pin on. The line that says pin mode red LED out sets the phantom pin as an output pin. The lines between the repeat and the until in key return the ASCII value, or the lines between there are executed repeatedly until a key is pressed on the terminal emulator keyboard, which is again what I thought. The keyword in key returns the ASCII value of the key, and -1 if a key has not been pressed. So it's just saying if it's greater than -1, in other words, ASCII 0 through whatever, which would be any ASCII value, then it breaks out of the loop and does the end command. The out D is the digital output command of Control Basic. There is an IND command, which we're not using here, which is an input command. The wait 100 causes the program to do nothing for 100 milliseconds. So that's really straightforward. Okay, I've extrapolated a little bit. I still need to change this line up here, but I have the pin mode set for the red, yellow, green, and blue, out, 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 out. I still need to establish those keywords, which I'm using down here. I haven't done that yet. But then I did build the wait loop, or not the wait loop, but the off and on part for the red, and then the yellow, then the green, then the blue, and just stuck them in there. So I have to go back up and insert a couple of more lines to establish those keywords. Okay, I've done that up here now. So I should be able to run this now, if I didn't make any screw-ups. Oops, Control-C detected. What's actually happening there is I fat-fingered it and put it into a single step mode, where every time I hit the enter key it's going another step. And okay, so I Control-W'd to get out of there, relisted my program, made sure it didn't change, and now I'm going to try to do this without fat fingering it. So that seems pretty simple. Obviously there's quite a bit more to learn here, but the The language is quite simple, and it is pretty much following basic rules. It's not using line numbers, and I'm old school with that. I always learned to use line numbers when programming BASIC, and Fortran and some other things I used to do in the old days. But this is more of a structured programming approach. So simply, I think indenting like this makes it part of the loop that occurs before the unindented command above and below. That's what establishes a loop. This actually does have go-tos and go-subs and commands like that, but it's recommending that you don't use those more than necessary, and that you follow a structured programming approach that calls key names and things. I hit any key to stop running the program. There we go. Okay, so it stopped. Alright. Success. This is a printout I made of the PDF manual for the BASIC, the Control BASIC as it's called, for the EZ SBC. Seems to be a pretty large reference manual. It's got, I don't know what it is, at least 80 pages now, maybe 60 some odd pages. I'll just run down the command list here. There's sections on repeat until, while, when, for, next, loops, order of operations, binary operators, and then the reference in alphabetical order. You've got things like trigonometric commands, absolutes, logical functions, you know, arc cosine, arctangent, ASCII manipulation, a bunch of commands here which are familiar to normal BASIC and some which aren't. Delays, something that looks like temperature. I'd have to look it up to see what that does. Get tick. A lot of these computers have a tick pulse. It's an internal clock, so maybe that's what that's for. Go sub go to. So these are I2C commands here, a whole bunch of them. And then again, some that look more like normal BASIC. In key, which has already been covered, that gets a key from the keyboard. Some specialized commands for pulsing. I think that's for reading input pulses, that's for generating output pulses. Pulse width modulation commands. I think these are serial commands for the serial communications. Servo command, a set tick function that goes back to what I mentioned a moment ago. Shifting in, shifting out, more trig functions, step, single step, I think, strings, looks like normal basic stuff there. Functions associated with real time, tone, string manipulation, and then we get into things that are not commands here. These are more how to download a program, delete a program, memory bank selection, running a program automatically, setting the time, resetting, etc. And everything seems to be pretty well laid out here. Looks like a pretty good reference book. So here's a overview of the EZ SBC product, and as I mentioned, mine appears to be the original one, but all of the instructions I downloaded refer to it as the EZ SBC 1, and the components are definitely laid out a little differently. It's clearly a different version of the board. Anyway, so what do we have on here? We've got the micro USB port for one possible power source. It can also be powered off of pins on the two headers. And then of course it has the serial communications through the USB. There's ground and 5-volt power. There's a reset. And then there's ports 4 and 5. I think those are, yeah, all these blue ones are the user port pins. Let's see, where do we go here? I'm guessing that the P here refers to a pin number, but I don't know in the program if they're referring to a literal pin number or if they're referring to these P numbers. Not sure. These two can be used, I think, as a serial port. I think that's what that's saying. These three go through an analog to digital converter, so you can use them, I think, as digital lines or as analog input lines, or maybe they're only analog, but probably they're programmable. There's a pulse width modulation function on P9, another ADC on pin 10. Pin 11 is apparently only digital. 12 and 13 also has ADC. 14 apparently is digital. 15's got another ADC. 16 is digital. And then there's this SPI function that's using 17 through 19, pin 20. Pulse width modulation or an ADC on pin 21. 22 is another ADC. 23 is digital. There's a DAC or an ADC on pin 24. 25 through 28 can use the ADC. More digital only pins. Here's two pins that can be transmitter receive serial or pulse width modulation, or pin 36 can be another ADC. There's a voltage reference, another ground pin. If you're going to connect a battery to it, you do it here. So again, very similar to the Arduino. I have not compared it to an Arduino Nano to see if the pins match up. There's a good chance that they do. It wouldn't surprise me if they did. They do provide schematics. Well, this is for the project board. That's the schematic for this thing, which is not what I want to look at the moment. There's the schematic for the actual EZSBC board. This is for the revision 1, or version 1, revision B. So we have, looks like basically 3 chips on there. I don't know if I recognize 3 chips or not. Again, I've got an older version here. This seems to have 2 chips on it, along with some transistors. I don't see anything on the back side of the board. Oh, I see what they've done. Okay, yeah, so U4 is the big chip there, and it's just broken up. There's U4 section A, B, and C, and then U1 is the other chip. And here's the dip pinouts. It's kind of interesting that that seems to disagree with this other diagram. Or maybe not. No, I think it does agree. Pin 40 is the VREF, and then ground, and then VBAT. Okay, so that's fine. Here it's calling all these pins dips, like digital input. I think they just mean dip pin 4. That's what they mean. Counting from pin 1, that's pin 4. So when they're saying P4 here, that is referring to the dip pin out, since 1, 2, and 3 are not I/O pins. The first one that is pin 4. There we go. 37, 38, 39, 40. So those are the literal pins, but for the program we're using 41, 42, 43, 44. So even though pins 38, 39, and 40 are not I/O pins, they're starting with pins beyond that, virtual pins for the LEDs. Anyway, back to this. There's a, looks like a voltage regulator on there. Some sort of a power management chip, or maybe that's a power on reset chip. There's the reset push button. There's the crystal, tiny crystal on there. I didn't even see it, but I knew it was there somewhere. I think that's it in the middle of the screen, right off the upper right corner of the big chip. USB, and it's wired into this chip. I'm thinking that smaller chip is what handles the serial functionality. Yeah, so anyway, pretty straightforward. There's a couple of diodes down here that are tying the battery or the 3.3 volt into the VRTC, which is apparently the power supply pin on the main chip, at least. So it looks like that's running at 3.3 volts. I'm not sure what the specifications on are this when you're using pins digitally, if they're running at TTL level or if they're running at 3.3 volts. Again, I'd have to read more of the manual for that. Or they may just be open collector, in which case it doesn't matter. The inputs could be threshold sensing at something lower than 3.3, so a 5 volt or a 3.3 or maybe even higher voltages like 12 volts would all be read as logical ones on the input pins. That could be the case. And then the outputs may all be open collector types, so they could only sync. That's quite possible, and that would allow them to work with a wide variety of voltages. And that may be why the turning a pin on in logic, as we did with the LEDs in that sample program, turns the LEDs on, because turning on a syncing output would cause whatever's tied to the output to be energized. Okay, I thought I'd cover a little bit of the EZSBC website, Controlling Your World the Easy Way, and it has kind of a Tasmanian devil type character. It's EZSBC.com. Most of what we design is aimed at embedded control. We manufacture in America. We use automatic equipment. We support what we design. Although they don't say technical support, they say we provide good documentation and a forum for technical questions. So it may not be that you get all that much direct support, and this could really be, you know, a one-man company for all I know. I doubt that with the number of products they have that they could support a big staff. So it may very well be just a very small operation. But let's take a look at products. So here's the their flagship product, the one featured first. It's $25, and they're calling it the EZSBC one here. It's an ARM-based 32-bit single board computer programmed in BASIC. Has 128K of program memory and 30K of RAM for the basic program, 64-bit floating point and 32-bit integer. There may be more, but that's where that stops. There's a screw adapter board, which you can put a socket onto or just solder the EZSBC into, and it just brings all the pins out to screw terminals. There's an IPEX to SMA panel mount connector. I don't know what that's for. There's an ESP32 ANT01 breakout and development board for external antenna connector. So I don't know what that is either, but it's something to do with an antenna. There's a SAM D21G18 development board, a ESPW Room 32 Rev, whatever that is. Guess I could click on some of these and see what it says. Doesn't describe it there. Let's see. Outstanding RF performance and space constrained applications. Supports sniffer station, blah 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 blah. Things that I'm not all that knowledgeable on, or hardly knowledgeable at all. Now we get into some of the other products that I mentioned. This is what actually brought me to the website first. Some people on a different forum said, hey, these guys have some pretty nice little switching regulators. The PSU2 ADJ for adjust is a adjustable 1 amp switch mode voltage regulator, high efficiency replacement for 3 terminal linear regulators. Presumably like the 7800 series, 7805, 7812, all of those. It's a replacement for that. And then they've got this product, the PSU7, which is a LM78H05K replacement, so the higher current package up to 5 amps for that series, for now obsolete 78 or LM78H05K. You can actually go up to 20 volts maximum on it, but it's 5 volts as you see it. As with most of these things, there's ways to get them to go to a higher voltage by offsetting their reference pins. Then there's the PSU5A 5 volt 3 amp regulator in TO220 form factors. It's a 2.5 amp switch mode regulator, replacement for the obsolete LM323T, 20 volts maximum out, or 20 volts maximum input. That's what this one was too. I probably said output, but it's maximum input. There's a USB to serial / UART 5 volt or 3.3 volt board. This looks like it's really similar maybe to the popular SparkFun adapter board. Here's the PB1 development board for the EZSBC. Here's a PSU5, which is similar to the PSU7, except it's a replacement for the LM323T. Oops, I didn't go far enough. For the LM325K. And here's the EZSBC2. It's similar to the EZSBC1, but it's based on a different CPU and it's somewhat less expensive. And here's an 8-bit or 8-channel bidirectional level shifter. Can be used to convert between 2 different voltage levels. And here's a 12-channel level shifter and buffer, convert up to 12 digital signals. The PSU2-3.3 is a 1 amp 3.3 volt regulator, easy replacement for three-terminal linear regulators. Another one in that package, here's another switch mode regulator, and another one, and another one. They've got a whole bunch. And then, you know, the power adapter, which is similar to the one I bought here. I didn't buy theirs, but darn if the thing doesn't look identical. I just bought this one on Amazon. I just plugged in the current and voltage and barrel type, and that's what I got. So I'm sure they don't make that, they just sell it. They have a little 84 by 48 pixel graphical LCD, as used in Nokia 5110, whatever that is, and with a white backlight, so you can use that. An ultrasonic distance sensor, a digital temperature and humidity sensor, jumper wires. That seems to be about their whole product line. So not a ton of products, but a lot of voltage regulators, and then 2 or 3 of these different products that are small programmable controllers in packages similar to the Arduino Nano. Anyway, by the way, you can download from the website a whole bunch of sample basic programs in the form of a zip file, and I'd have to read the manual some more to see about how to load those into the product. I'm sure there's a way to do it. It's probably very simple, but those are all you know, programs that you can study, learn from how to do various things, demonstrate various features of the product.